We've talked about a lot of different special situations to do inference. We've talked about one proportion, one mean, difference of proportions, a difference of means, and now we have one more kind of special case, which is the paired difference in means. So this is section 6.5, and it doesn't have the little subsections that the other sections do. It kind of sticks everything together. But that's because it calls back to previous sections. So this section is about paired data, and paired data is when there's some natural pairing in the data set. And so probably the easiest and most common example you'll see of this is twin studies, where maybe they do an experiment. They do something to one twin but not to the other, and then that data is naturally paired because the twins are a natural pair. Sometimes you'll see naturally paired data that does like pre and post testing. So we have someone do a math test and then we have them, expose them to some stimulus, and then we have them do the same math test again. We see if they improve. And that data is naturally paired because I want to look at your math test before and your math test after. There's an idea of matched pairs. This sometimes is used in educational studies where they will take students that are different, and they'll make sure that they have a lot of similar demographic considerations, that they are the same gender, the same race, the same age, their parents have about the same level of education, they're about the same income. So they'll match up on many demographic characteristics, and then they'll do something to one group and something different to the other group. And then that matched pair will turn into not a natural pairing, but it's a pairing that you can think about. So those are situations where data is paired. And so I have an example here. This is data on a random sample of 73 textbooks from UCLA, which is where I got my PhD. And I'm just showing you, I think this is the first 6 rows of the data. So there's more rows of data. There's 73 rows of data. And some researchers went out to the UCLA bookstore and they found the price of a particular textbook, and then they found the same price on Amazon. And this data is a few years old, but I think it's still interesting. So if you look at this first row, this is from, looks like American Indian Studies. Here's the course number. Here's the ISBN. That's like an identifier for a book. Here's what the book costs at UCLA in the bookstore, new, $27.67. And then on Amazon, it costs a tiny bit more, $27.95. And then there's this variable more, which is just were there more books required for that particular class. And then I could look at, I've got some anthropology books, I've got some art history books, etc. And looks like it's in alphabetical order. So we can look at this data, and the data is naturally paired because we have the same book and we have the price at UCLA and the price on Amazon. So you could think of that kind of like multiple measurements on the same observation, kind of like a pre and a post test. We've got the UCLA price and the Amazon price. So we could do the analysis unpaired. That's what we were doing in section 6.4. That was the difference in means section. We could do inference on the unpaired data. It looks like my video is blocking some of the information, but the average price of a textbook in the bookstore, so X bar in the bookstore, was $72.22, and the X bar on Amazon was $59.46. And then we also have the standard deviation. Standard deviation for the bookstore was $59.66, and the standard deviation on Amazon was $49 even. The N is the same for both groups. So the N for the bookstore is 73, and the N for Amazon is 73. So we could do the analysis like we did in 6.4 and do unpaired analysis. So we're going to make a confidence interval for the difference of these two means, the average price at the UCLA bookstore and the average price on Amazon. So I'm going to go through my usual steps. I'm going to do the point estimate. I'm going to find the critical value. I'm going to find the standard error. I'm going to check the conditions. I'm going to make the interval, and I'm going to interpret. And I think I've given myself another blank page, so I'm actually going to just copy all of this over so that I have more space to work. That, and then I'm just going to move this up here so that I remember what to do. Okay, so my point estimate, if I'm doing the analysis unpaired, the sort of 6.4 way, I'm going to do X bar for the bookstore minus X bar for Amazon. That's going to be 72.22 minus 59.46. So my point estimate is $12.76. The average for the bookstore is higher than the average for Amazon. So that's my point estimate. Then I need to find my critical value. And the critical value is going to be a t-star value. And it's going to come from a t-distribution where the degrees of freedom are the minimum of n1 minus 1, n2 minus 1, which in this case is the minimum of 73 minus 1 is 72, and 73 minus 1 is 72. The minimum of those two things is 72. So let's go to StatKey and find that critical t-star value. So here I am on StatKey. I'm going to go to theoretical distributions, click on the t-distribution, and then I have 72 degrees of freedom. Okay. To tail. Oh, and I didn't specify if we're doing 95% confidence interval, so let's just assume that. That's usually the safe assumption. So my critical t-star value is 1.993. So t-star is equal to 1.993, so I've got that critical value. And then I need to find my standard error. And for this one, I'm going to use that formula from 6.4. It's the S1 squared over N1 plus S2 squared over N2. And so in this case, it will be 59.66 squared over 73 plus 49 squared over 73. 3,559.3 over 73 plus 2401 out of 73, or that's the square root of 16.25 plus 32.9, the square root of 49.15. And what is that? It's basically 7.01. That's my standard error. Great. I need to check the conditions. I need to make sure that N1 is greater than or equal to 30 and N2 is greater than or equal to 30. And I've got 73 and 73, so check and check. And now I can make my interval. Maybe I'll scoot a couple of these things over a little bit. So I can do my point estimate plus or minus the critical value times the standard error. And I've got all those numbers now. 12.76 plus or minus 1.993 times 7.01. And then I'm going to multiply 1.993 times 7.01. That's my margin of error. 12.76 plus or minus 13.97. And so 12.76 minus 13.97 is negative 1.21. And 12.76 plus 13.97, that's 26.73. Okay, so now I can do my interpretation. I am 95% confident that the mean price of textbooks in the UCLA bookstore is between $1.21 less and 26.73, we'll put dollar signs in front of them, more than the average price on Amazon. So when we do this analysis unpaired, we don't know which is more expensive. We've looked at the average at the bookstore and the average on Amazon. I'm 95% confident that the mean price of textbooks in the UCLA bookstore is between $1 cheaper and $27 more expensive than the average on Amazon. So that's the conclusion from doing this the kind of 6.4 way. But of course, we're in section 6.5, so we're going to do it a different way now to compare.